Hello students, in this video we'll see an example of how we can use discrete probability distribution to find the probability of a certain event. Let's suppose that x is a discrete random variable with values in the set 1, 2, 3, just the counting numbers, and such that the probability that x is equal to k is some parameter lambda times 3 to the negative k. We would like to find the probability that x is a multiple of 3. Well, we're given the entire probability distribution, so we know that 1 is the probability that x equals 1, or the probability that x equals 2, or the probability that x equals 3, and so on. And so this is an infinite series. It's simply just the sum, n goes from 1 to infinity, of the probability that x is equal to n, which we know is the sum, n goes from 1 to infinity, of lambda times 3 to the negative n. So now we can recall that the sum, n goes from 1 to infinity, of x to the n is x over 1 minus x. So this series over here will simplify, and we know this has to be equal to 1. So this will simplify to lambda, and then now my value of x is 1/3 here. So if I plug in x equals 1/3, we'll get what we want. So then I'll have a 1/3 over 1 minus 1/3. So this is 1/3 over 2/3. 1/3 over 2/3 is just equal to 1/2. So this is lambda over 2. So if lambda over 2 is equal to 1, that tells me that lambda has to be equal to 2. So lambda for us will be equal to 2. And now we can update our probability distribution. The probability that x is equal to k will be 2 times 3 to the negative k. So now we can return to our problem. Our problem asks to find the probability that x is a multiple of 3. The probability that x is 3, or the probability that x is 6, or the probability that x is 9, and so on forever, is also an infinite series. It's the sum, n equals 1 to infinity, the probability that x is equal to 3n. And now we know what that probability is. So this will be the sum, n goes from 1 to infinity, of 2, and then times 3. Instead of k, I will have a negative 3n. So I'll have negative 3n over here. And so now it's the same formula we have over here, but instead of x being equal to 1/3 over here, x will now be 3 to the negative 3 power. So we'll have to plug that in. And so of course 3 cubed is equal to 27. So now with this formula we can say that this will be equal to 2 times, common ratio is 1 over 27, so I'll have a 1 over 27 on top. And then I'll have a 1 minus 1 over 27 in the denominator. So this will be 2, and then 1 over 27, and the bottom will be 26 over 27. So this will be 2 over 26, which is 1 over 13. So 1 over 13 is the probability that this discrete random variable is a multiple of 3. Thank you very much.